Hello, this is manufacturing system week 3. So this week prepared two modules. Two modules are related to material. So in manufacturing system, so material is a key concept to understand the process of manufacturing because manufacturing, I defined that manufacturing is as converting resources into useful product. To convert to understand the process of converting into a useful product, we need to understand the concepts of material. So this week, I have two modules, but this is the first module, and I think that these two modules will be tough to understand because last week we just touched the basic concepts of manufacturing system, but this week we're gonna go into the scientific or engineering concepts of manufacturing. So this module is material and manufacturing. And the second module, I will talk about the structure of materials. And this class have 5 objectives. So we can see these objectives, but in this class, I want to highlight the relationship between material and manufacturing, how they are related, and distinguish between organic and inorganic material. Those are simple, but the other one lists the 3 major types of material and identify and describe the metallic, polymeric, and ceramic materials and give example of composite material. So those are keywords. So alloy, carbon steel, and ceramic material. Those are we heard a lot these terms in daily life a lot from many product, but this class we will learn about the how these materials consist of with their elements. All right, so the first one, so I'm gonna go back to the definitions of manufacturing. So manufacturing, uh, last week, sorry, we we agreed that manufacturing is a process of changing resources into more useful products. So to understand the process, we need to understand the resources, the characteristics of resources. Because we need to select or make a decision which material we are using for a specific product. So then when we make a decision, we need to choose based on the fundamental understanding of resources. So there are lots of variety of types of resources, so, such as metal, plastic, or ceramic, such as glass. So, but we in this class we will look at the uh, how the materials formed or how we can convert the rich material into useful product. And most materials require processing before used, such as this picture is illustrating how metals are converted into useful products. So this is a furnace. So people pour metal ore, I'm sorry, iron ore. So this is the stone, and then with a charcoal and limestone, those are basic element of steel, and then that melt and then cool down that produce useful products such as pig iron or other materials. So this is the example. So aluminum also come from bauxite. So this is the example of manufacturing. This is a part of manufacturing. And the materials used in manufacturing, there are two types of materials: organic, organic, and inorganic. So as you guess from the term, organic is from living things such as like plant or animal, people like died, and then they like the microorganism like um, microorganism work with those dead debris and then convert into coal, petroleum, wood, and wools. Those are organic material. But inorganic is from non-living things such as copper, gold, uh, aluminum, glass, cement, and rocks. Those are inorganic material. And then all material has three physical states: gases, liquid, and solid. Those are basic physical status. But most of products we are using in the manufacturing are solid status. And we're gonna use the term engineering material. So the term engineering is human-made. So engineering material is human-made material. So we can use the resources from organic or inorganic, but engineering material means we convert the resources into secondary product. That is engineering materials. So and we call engineering is a solid material, not liquid or gases, because they hold their shapes, certain shapes, without outer support. And then the engineering material has four categories: metallic, polymeric, ceramic, and composite. So we're gonna just look at each materials. And keep in mind, so non-engineering material is gas and liquid. So engineering material is a solid. All right, the first thing, the metallic material. So it's just like metal material. So three characteristics. First of all, inorganic. Metallic materials are inorganic. And crystalline, that means has a specific form or specific shape. And substance. So those are three characteristics. So let's look at this example. So crystalline and non-crystalline. So you can see this dots that represent the molecular structure of a resource, a object. So crystalline means that has certain pattern like this and this pattern. But you can look at this non-crystalline. This one, there's no specific pattern. That is just formed randomly. But metallic material characteristic is crystalline, has a certain form or a certain shape in their molecule structure. That is characteristics of metallic material. Most commercial metals obtained from their ores. So, for example, aluminum come from aluminum ore. We call it alumina. And copper, chromium, nickel, all material or metal come from their ores. And seldomly use their pure state. That's the important. I will further explain about this, why we are not use the material in pure state. It's very important. I will explain further about this one. And combine with other material to produce alloy. So because we can use the pure state, so that's why we mix lots of other things. So one example is iron. We don't use a pure iron because iron is very not solid, not enough strong. So that's why we add more carbon and other materials that make carbon steel, that more sturdy material. And there are two types of metals, ferrous and non-ferrous. So this ferrous is the primary material of metal is iron, ferrous, but non-ferrous material doesn't contain ferrous. That's the two differences. All right, first look at about the ferrous metal. Ferrous metal has iron, come from iron, and then called Fe, that's in a periodic table. So you have to look at this. These are ferrous metal. So the knife or like spoons or steel, carbon iron, those are examples of ferrous metal. So ferrous metal has characteristics such as, first one is contain iron, that is a first requirement. And then second is lower resistance to corrosion, that does not easily corrode. and magnetic and strong, rigid and cheap, and silver light color, as you can see, and then recyclable, because metal, ferrous metal can be melt and then can make a reshape. So that's why it's recyclable and good conductor of electricity. And then I want to add one more, heat. Good conductors of electricity and heat. That means they deliver heat well. That's why we're using the cast iron for like pan. And then ally with the varying percentage of iron and carbon. In the previous slide, I told you most of iron has iron combined with carbon to make a certain product. So 90% of iron products are contain carbon. And then based on the percentage of carbon, we classify different types of ferrous metal. So first one is pure iron. So that does not have almost pure ferrous. There's no carbon, the pure iron. And second is carbon steel that contain 0.1 to 1.55% of carbon in their structure, and iron, more than 1.5 carbon. So because carbon determine the mechanical property of the ferrous metal. So this is a metal, ferrous ore. All right, so look at deeper about the ferrous classification by carbon, percentage of carbon. So this is pure iron. As I told you, you may have seen this types of pure iron in your daily life because that is very malleable. So that means easily bent or fragile. So that's why we don't use the pure iron for the metallic product. Instead, we are using carbon steel or cast iron or other alloy materials. So carbon steel is most widely used metal in the world. So as you can see, there are structural material or very sturdy metal is carbon steel, because by adding 0.1 to 1.5 of carbon, that the iron becomes more sturdy, more rigid. I will explain further why. Cast iron is more than 1.5 carbon, so that's cast iron that it has high resistance to corrode. So that's why we're using this for fan. But that is also brittle, easily breakable. So, and we need to ask why, because that's why we are learning this module. So we need to ask why pure iron is not good for a metallic product, or why cast iron is brittle. Let's look at here. So I told I put the name Hidden Secrets of Steel. So this is iron, pure iron, like Fe. This is natural status of iron. And this is carbon. So carbon is a primary element of diamond, and carbon is widely used in the many manufacturing products. Thus, without combining with carbon, this iron is like this human. It's fragile. It's not strong. But just adding iron with carbon, that become more strong, like Iron Man. Why? I'm gonna explain this one. So let's look at this as a metal, and that the circles big circle represent ferrous atom, and small circle is carbon atom. So there are lots of atoms because natural, no, not natural, but the metal products, most of metal products contain certain percentage of carbon to make a stirred. So I showed you so high percentage of carbon or low percentage of carbon in metal, in iron. So there are two examples. So first one, low carbon, and second one is high carbon. So the big one is Fe, iron. Small one is carbon, right? So the first one, left one, has 6 carbon with lots of phosphorus. The second one has more higher number of carbon in their structure, right? And let's say so to this metal product we push stress, push force like this, like to squeeze, and then second one also we did like this. And let's guess, how does the metal, the iron product react to the pushing force with low carbon or high carbon? We can compare this just two to understand the mechanical property depending on the percentage of carbon. The first one, I squeezed on the side, and then the structure of the iron changed by the product, by the force from outside, right? That's changed. So we see many metal products that is like malleable or ductile. That is like this example that has low carbon in the product. But the second one, or medium or high number of carbon, let's say, from here and push. Do you see the differences? Just ignore this high carbon. Just a high number of carbon, not medium. So just this. Let's say this high. Do you see the differences? Yeah. How does the high carbon product react to the forces? Yeah, that does not move well because why? Let's say that you can see the carbon that prevent moving the molecular structure that hold with ferrous atoms, right? Yeah, that's why the high carbon is usually brittle, but not ductile, not malleable. But low carbon is more likely malleable than high carbon because there are more space to move, to react from the outer outer forces. And then we push more power, that like break, right? We can see this example from cast iron. So cast iron is very sturdy, very rigid because of the carbon that hold the structure from the outer stress. But after getting more certain level of getting stress from for the certain level, and then that break up. But low carbon usually not break up, but not broken. That's the differences, right? So let's apply those concepts into actual product. So carbon steel. So carbon steel has carbon up to 1%. So that we call carbon steel. So carbon steel has different level of carbon steel: low carbon, medium, and high carbon steel. So as I explained, low carbon steel has characteristics of low strength but high ductility. You can see this like metal string, right? That is easily like you can bend or you can stretch, but low strength. So, and then this is able to cold working to increase metal's hardness. So no heat treating. So without heating that, we can just convert that product, right? Most of metal products need high temperature to change their shapes or form. But these types of carbon, we don't need to have high temperature. That is cold working, that allowed cold working. And the medium carbon steel contains 0.3 to 0.55%. So the available heat treating, and then structural application is automotive and machinery. Most of carbon steel products are this medium carbon steel. So these examples are gears, because very sturdy, and high carbon steel, that is the high that have highest strength, but is hard and resist wear and coarse material, available heat treating, but after getting certain level of stress, that is brittle. So this is high carbon steel, very sturdy, very strong. So we are using string and saw blade and piano wire and drills. Those are high carbon steel. And there's another types of high alloy steel. So with carbon, the ion is adding more different types of alloy, different types of metal. So first example is high speed or tool steel. We call it high speed steel because the name from this one. So when people made a product with this metal that cut faster than high carbon steel, that's why they named high speed steel. And this has higher amount of carbon than other metal steel products. So it has heat resisting alloy because like driver bit gets a high temperature while working on certain work, but that resists high alloy. So in the high temperature, that does not easily change their shape and hold their sharpness on the high temperature. That's why we're using this type of steel for this drill bit and cutting tool or forming dies. That's their usage. And the other types of high alloy steel is stainless. So you can see this types of stainless. Stainless steels are very widely used in our daily lives, such as like this cookware or car or airplane. They are using already stainless steel. So this common alloy is carbon and chromium. So the basic principle of stainless steel is, let's just say this is carbon steel. So this is a ferrous atom. Let's say this Fe. But what does it mean that a metal product corrode? Why this the product corrode? Because the ferrous in the natural status, ferrous has a tendency to combine with oxygen. So in the natural world, there are lots of oxygen, right? So when ferrous meet oxygen, that made a molecule structure FeO2. This is their tendency, their chemical property. So that is corrode. So by meeting ferrous atom with oxygen, that become fragile. So that's why stainless steel is adding another layer of different product, different property, such as carbon with chromium, that adding another layer that protect the surface of these items. So that's why stainless steel is resistant to corrosion, right? So high corrosion resistance and adding a layer of anti-corrosion material. That is example of carbon and chromium alloy from here. So stainless steel can be corrode when there has some like defect or some damage here, like here. In our cooking ware, we make a scratch. Then what happened? That corrode, because the oxygen attacked this metal product, right? Oxygen goes into the metal product, and then they become the ferrous dioxide. That means corrosion, right? All right. So let's look at non-ferrous metals. So there are many non-ferrous metals. So look at these examples: copper and brass, aluminum and tungsten and lead. So aluminum is the most the aluminum is most widely used the metal product from on the non-ferrous metal. So these types of metal do not have iron in their principal ingredient. So I chose these examples, and I will just look at some examples of non-ferrous materials. So first one is aluminum. So that is non-magnetic and malleable and heat and electricity conductive and lightweight. That's why aluminum is widely used in manufacturing. And heat and electricity conductive is also important. So that's why in the making projects in technology classroom, sometimes we use aluminum tape to connect electric parts. So that's why aluminum is widely used. And that's obtained from bauxite, from this like aluminum ore. So commonly found in clay, these types of ore. And bauxite is aluminum plus oxygen, so that's bauxite. And then we purify from this ore by removing oxygen from the bauxite. That's the aluminum product. And copper and copper alloy. So this copper is very interesting because that is also related to the human development, like historical period. I'm going to show you different slide in the next slide further about this story. Anyway, the copper is called Cu in periodic table, and first metal used by human. This is first metal used by human. I'm gonna ask him why people use this copper than other metal products. That's also important question. You can also think this question with your students. And this feature, top, ductile, conductor of heat and electricity. That's why we use copper for electric wire. And copper alloys, there's a lot of example. Brass, so like copper from zinc, called JITN. So that is example of brass. So it's a fun story. When people first found the brass alloy, copper alloy brass, they believed that is gold. So that's why they thought, okay, we can make gold. We can engineer gold by combining copper with zinc. But later they found that it's not actual gold. They really disappointed. Anyway, the brass is decorative item, lighting fixture, and plumbing fixtures. The differences from brass from gold, the brass is less tough, it's more ductile. That's differences. Anyway, and bronze, this is our first use of copper alloy, that's bronze. So copper plus tin, that is bronze. Like fusible, that means ready to melt. So this is example. So that's why people use this copper alloy, bronze in sculpture and then other many tools, and has a resistance to corrosion. So you can see this sculpture, like it lasts for maybe more than 1,000 years, and then keep the same structure. And tool and weapons they made it using bronze. And also there are another types of copper alloy, copper plus zinc plus silver, that's nickel silver. So silver plate dinnerware or spring electronic connector, that's nickel silver. And let's look at here. This is historical period, like human, that is classified by tools and weapons made by human. So Stone Age, people made tools and weapons using stone. That's why they define Stone Age. And Bronze Age, that is widely used bronze for like tools. And Iron Age, those you can see their ages, like prehistoric, BC 6000, BC 2500. But why? Why people first use the stone and later they use the bronze before iron? That key is melting point. Melting points are different. Because let's look at here, like brass. Yeah, brass is the melting point is almost 16 to 1700 Fahrenheit, right? That's brass. And bronze has 1700 as melting point. But also you can ask why people don't use the age, brass age, because brass is not enough top, not enough third to make weapon or tools. So that's why they just defined the bronze. That changed their life. Before the Bronze Age, people only can make the tools and weapon using stone, right? The cutting and honing, that's their only they can. That these are only their skills used to convert the product. But at this time, they can able to make bronze product, like bronze weapon, bronze cookingware, anything, because melting point, the melting point. And copper is 1900, and iron is 2800 Fahrenheit. These development or evolve are depending on the melting point. I mean, the human's skill to make efficient furnace. So to make bronze product, what people need? So they need to make a nice furnace using like stone. But have you thought about how people can make this temperature? 1700? It's very, very difficult. They are very secure this furnace, right? And then they need to have skill to add more like fuel, such as charcoal or other materials to make this temperature. That means BC 6000, human finally found a way to make efficient furnace to melt copper, like bronze copper plus tin. So they just finally made this temperature with materials. They did lots of experiments to make more stronger weapon or stronger products. But finally they made using this bronze, right? And iron is higher temperature. Iron needs high temperature to melt. That's why the melting point decided historical human history. Does it make sense? All right, and I have a few more slides. So polymeric materials, so we called like plastic. So this organic or non-crystalline. So carbon and hydrogen is their primary materials, resources for polymeric. So carbon tend to combine with hydrogen. So these types of material we called CH4 methane. So carbon is very used to carbon like hydrogen. I will explain why carbon like hydrogen, but this is polymeric material. And then this is one composite, but these types of carbon and hydrogen tend to connect with other molecules, and then they can change like chain-like structure, like C, and adding hydrogen because carbon like hydrogen. Yep. Like this kind of structure, chain-like structure. That is we called plastic, and we said polymeric material. So that's why form long and chain-like molecule structure with carbon backbone system, such as. And polymeric material has two types: natural polymers from nature and synthetic polymers, plastic. So nature is, you can guess, like wool, latex, and cotton, silk, flax. If you look at the molecule structure very closely, you can see their molecule structure that is like carbon, like chain-like structure. But those are enough. Those materials are not enough. So that's why people make artificial polymers. That is called synthetic polymers, plastic. And yeah, so most of synthetic polymers came from petroleum, like oil, natural gas, or plant fiber. Because petroleum and natural gas and plant fibers, their primary material is the carbon and hydrogen, almost the same as natural. Because engineers they copy the function and shapes from nature. So, and then there are three types of plastic, and there's among the three we need to highlight just two differences: thermoplastic and thermoset plastics. Right, so let's look at thermoplastic and thermoset plastic. Before we look at their molecule structure, this is their example: thermoplastic left, and right is thermosetting plastic. Can you see the differences between two products? How different? What are the characteristics of two? Yeah, feature. the summer plastics are high strength and shrink resistance and is the bendability, high bendability, right? You can bend like the certain plastic, but other types of plastic are not bendable, like enhanced chemical resistance and heat resistance and structural integrity. So those are two differences, like this. This one, the pen cap, is this summer plastic or summer setting plastic? It can be summer plastic because it's bendable, right? And this one, this pen, this is summer plastic or summer setting plastic? This is summer setting plastic, not bendable. But the key idea that distinguishes the two products is recyclable. So most of summer setting plastic are not recyclable because after just melting, when they make this product, they melt and the like make a shape, so like this. But the summer setting plastic, after they make this, they cannot be remelted. That's the differences. But why? We can find the answer from their molecule structure. Left one is thermoplastic polymer. These are like carbon and hydrogen like molecule, like this chain-like molecule that like this form, and then thermosetting polymers like this. But differences are thermosetting polymers have cross links like here. So each molecule strings are connected. So that's why the thermosetting plastic that cannot be recycled. When gets some heat, thermoplastic polymer that disentangle the strings and can shape another types of products. So when we put heat like here, these strings can be reshaped, make a shape, different shape. But this one, we put heat, just melt, and then the melting means that like dissolve their molecule structure. They lose their molecule structure, right? That's just bond. That's it. So that's why thermosetting plastic cannot be recycled. And the pro and cons. So these are like high school level contents. So there are pros and cons. So of course, so thermoplastic has highly recyclable and aesthetically superior finish, high impact resistance, and yeah, but the pros of thermosetting plastic is more resistant to high temperature than thermoplastic, and highly flexible design and thin to thick wall capability, and like a stability, high level of stability, and those are there. And the cons can melt if it heated. I don't know. This can be pros or that is categorized by cons. But here that is big cons of thermoplastic. Thermosetting. Thermosetting cannot be recycled. That's the big problem in thermosetting plastic. All right, and then synthetic polymer. All right, so we call the plastic the synthetic polymer that's first invented by John Wesley Hyatt to replace the natural ivory in billiard ball. Humans are brutal, right? So in 19th century, people play billiard games, but they need more billiard balls. So their primary resources to make the billiard ball was ivory, from elephants. So they killed a lot of elephants. But to replace the natural ivory, the people finally invented a synthetic polymer that resemble the natural ivory in terms of shape and mechanical property. So that's a good thing, right? And they're made of organic chain called monomer. So this is monomer, right? So as I told you, so carbon really like hydrogen. So that's why they make like this structure. But when monomer meet another monomer, a monomer meet another monomer with heat or other treatment that tend to be combined and tend to make this like polymer structure, like carbon with hydrogen. And depending on the shape or forms of this molecule structure, there are variety of polymer products like ethylene, vinyl chloride, and styrene, polypropylene, acryl, lots of polymer families. And ceramic materials. Ceramic is one of the oldest material used by human, because human history started with Stone Age. So stones are ceramic materials. So these are inorganic and crystalline material, like stable and not affected by heat, and from clay. And one of the ceramic materials is cement. Cement is a type of powder, and by adding water, they make solid cement. So we use the cement in our technology projects. And yep, that's it. So those are. And then another type is composite. So composites are a combination of two or more material in chemically and designed to overcome weakness of another products. So example are fiberglass. So let's just think about the cons of fiber and glass. So this is example of fibers and glass. By adding the two materials, make more stronger but highly flexible, because fiber is flexible but glass is fragile, brittle. By adding two materials that become more, they can get advantage of two material properties. We use these fiberglass for insulation and textile, and concrete is also example of composite, because concrete combine cement with sand and gravel that are concrete. So that helped the cement more sturdy. That's concrete. All right, those are our module 1. We look at a variety of materials, and then the second module, we look at the structure of materials, and then we can ask another why question. Why do we need why does a material has certain properties? All right, thank you for watching.